Okay, all right, this second video for scientific notation, we're going to do the opposite now. Now we're going to start with the actual number, and I want to put it back, condense it into the more efficient scientific notation. Now, first thing you can take down is how scientific notation expressed. We can put that, it's a times 10 to the 10 times 10 to the n. N could be positive or negative. Here's the main thing to remember. This a value, now it's got to be greater than or equal to 1 or less than 10. This is, kind of more of a fancy way of saying this a, it's got to be a single digit, meaning it can't be a double-digit number or anything above. Okay, I want to keep it simple, so let's just make it a single digit. Now, what I mean by that, let's look at the example. If we have this number, 7,623, now the decimal is at the end. It's right here. So I want to move the decimal so that a is a single digit. Well, I would have to move it between the 7 and the 6. Right? So I would move this to the left 1, 2, 3 places, so it becomes 7.623. I don't want it to be 76.23 because that's a double digit. So I move it 3 places to the left. Now, since I moved the decimal to the left, now it's going to be the opposite of what we did. You might be thinking, oh, the exponent has to be negative, but really it's going to be reversed. The exponent will be positive. I'm just going to put here positive. So I moved it to the left 3 places. So this, in scientific notation, is 7.623 times 10 to the third. Sometimes we get confused of saying, well, if I move it to the left, is it negative? But now it's positive. That might confuse students. Here's the easy way to remember it. This is a big number, 7,623. So when you put it into scientific notation, you should be left with a positive exponent. So I'm going to emphasize that more. That makes more sense. Okay, let's look at the next example on the back side of this page. Okay, now this one's going to be when we have, it's a very small number. This is going to give us a negative exponent. Now the decimal, it's got to go between the 6 and the 7. So I'm going to put 6 and the 7. So if I move this, I'm going to move this to the right 1, 2, 3, 4 places. So it's 6.789. Now that's a single digit, 6. You only have one number to the left. Now since you moved, we say to the right. Again, I really don't like emphasizing that. Here's what I would do. This is a very small number. So if it's a very, very small number, I know my exponent. It's got to be negative when I put it in scientific notation. Now I moved this, 4 places to the right. So your answer is going to be 6.789 times 10 to the negative 4. Okay? So easy way of thinking of this. Now you can see the problems right here, 1 through 8. I would always ask yourself this. All right, is the number very big? If the number's big, when you put it in scientific notation, the exponent has to be positive. If the number is very, very small, then that means the number or the exponent has to be negative in scientific notation. Okay, so if I look at number 1, okay, first thing, this is a big number, 6,387. So I'm going to put plus. That means the exponent's going to be positive. Now the exponent is here, or excuse me, the decimal's here. So if I want to get the exponent to be a single digit, I have to move this so it's between the 6 and the 3. So I move it 1, 2, 3 places between the 6 and the 3. So it becomes 6.387 times 10. Since I moved it 1, 2, 3, it's times 10 to the third. Okay, if I did, let's say I skipped to number 3. Again, a very, very big number. That's 41 million. Here's the decimal at the very end. So I move this to the right, 1, 2, 3, 4, 5, 6, and then 7. So it's between the 4 and the 1, so it's 4.1. Right, 4.1, that's less than 10, times 10, and what did we move it over? 6 places, or 7 places? Moved it over 7 places, so it's times 10 to the 7th. Okay, then if you look 4 through 8, these are very, very, very small numbers. So all of these, I'm going to put a minus. It's going to give me negative exponents. I know that right away. So number 4, I want to move all these decimals, 4 through 8, to the right. So I want to move 4 between the 3 and the 1. So it's 1, 2, 3. So this becomes 3.157. Again, 3.157, that's a single digit. There's just one number to the left of the decimal. So if I move this, let's see here, what, 1, 2, 3 places to the right, it's times 10 to the negative 3. Very small number, we get a if it's a very small number, that means we get a negative exponent. Okay, let's just do one more. Let's do number 6. Again, it's a very small number. It's going to be a negative exponent. Let's count. I'm going to move this number right here. I'm going to move the decimal place right here between the 8 and the 1. So let's just count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I'll put 9 for 9 places. So that becomes 8.14 times 10 is a very, very small number. So it's times 10 to the negative 9th. So that's our answer right here. Okay? So biggest thing that you should get out of this little video tutorial, if you put a number in the scientific notation, if the original number is very big, you get a positive exponent. If the original number is very, very small, that means you're going to get a negative exponent.